This is part 2 of our sequences. So this type of sequence relies on the previous terms of the sequence to create the next term. So like this. This is our most famous one. This is Fibonacci sequence. It starts with 1, 1. And then to create the next term, you add them together. So 1 plus 1 is 2. And then you just keep adding the previous terms. So 1 plus 2 is 3. 2 plus 3 is 5. So what's happening is we are adding the previous two terms to create the third, and then the second and the third to create the fourth, and then the third and the fourth to create the fifth, and so on and so on. That's Fibonacci sequence. So we end up with this kind of thing going on. And what this is this is our first previous, and this is our second previous. So what it means is this is one term back. So this right here would be our a n minus 1. And this is our a n minus 2. And if you plug in the numbers, you think about it, this is a sub 3. So this would be 3 take away 1. And then this would be 3 take away 2. So that's how it works. So that's 3. So that would be 3 minus 1, 3 minus 2. And so a1 and a2 are actually given. That's where we started. So if we plug those in, plugging in 3, you would get 3 minus 1 and 3 minus 2, which is a sub 2 and a sub 1. So 1 plus 1 is 2. And so it's just a nice general term that allows us to create the Fibonacci sequence. See, there's a 2 plus 1 is 3. And then so plugging in 5 would be 5 minus 1 and 5 minus 2. So 5 minus 1 is 4. 5 minus 2 is 3. So we use a sub 4 and a sub 3. So we use our a sub 4 and our a sub 3. And we get 5. So we end up with this Fibonacci sequence. So the first 5 terms are 1, 1, 2, 3, and 5. You can also use your calculator for this. So we start by clicking the y equals button, and it's not y anymore because we've already changed it to sequence mode. Remember, we hit mode and sequence. And so now to do this, what you want to do is enter this in as a new general term. And so we're going to use a is our u. And so you'll say u, and that's the number 7 in blue, parenthesis, and then we say n minus 1. That's our sub. So this is really a sub n minus 1. And then it's plus. And then we do it again. Second u, parenthesis, n minus 2. And so what this means is it's u sub n, and then that would be u in its previous one. And then this is the one 2 previous units before, right? So everything's set up. But what we have to do now is, since we have these in here, we need a starting value. So to do that, that's what our u of n min means. And we hit second, and then this is our brace, and you put in the first 2 elements with a comma, like that. So since we have an n minus 1 and an n minus 2, we have a 1 and 1. If we had an n minus 3, we'd have 1, 1, and 2, right? But that would be weird on this situation. All right, so everything's set up. We know our table is set up from last time, 1 and 1. So second table, and there they all are. So 1 and 1, we already knew that, and then there's 2 and 3. So you can see it's just adding them together. And that's how we enter it in the calculator. All right, let's try another one. So it says find the first 5 terms of the sequence. So all you're really doing is plugging it in. So we say a sub 1, and then that would equal 2. A sub 2 is, because see, it already says a sub 1 is 2. So a sub 2 would be a sub 2 minus 1 plus 3. So this is a sub 1 plus 3, which would be 2 plus 3, which is 5. So you can see all it is this right here just means previous term. So plugging it in over and over again mathematically is fine, but you can just say, well, a sub 2 then, 3 would be a sub 2 plus 3. That's what it means. So a sub 3 is a sub 2 plus 3. What was a sub 2? 5. So 5 plus 3 equals 8. And so you can see all this means is add 3. So a sub 4 would just be a sub 3 plus 3. It's 11. And so a sub 5 would just be, and we don't have to even go back, it's 11 plus 3, which is 14. So you can see all this means is take that previous term and add 3. And so those are our first 5 elements. So it's 2, 5, 8, 11, and 14. Okay, so let's look at another one. So this is an alternating sequence, and you'll see why. We have a negative 1 here, and that means we have an error. So let's put a negative here. Now everything's good. So you'll see when we do our first one. So we're going to just plug in a sub 1 first. And so that would be negative 1. And I'm going to leave the ends off and then come back and plug it in. So like this. So that's all it is. These are now exponents. So we put a 1 here, a 1 here, and a 1 here. And so what does that give us? So that's negative 2. So let's try it again. You can see where my error was. So this would be negative 1 and 2. And then this time I'm plugging in 2. And so what happens when you square a negative? That's right, it turns positive. So this would now be positive 4. So you can see why it's alternating. Let's see what happens with a 3. So same idea. Negative 1 to an odd would just become a negative 1. And then that's 8. So that's negative 8. So you can see how it alternates. It goes from a negative to a positive to a negative, and then so on. So that by putting a negative 1 with an exponent, like the n, it allows us to alternate them. Okay, so a sub 4 then would be negative 1 and 2. And we plug in 4. And so that would become 16, which we already knew. And so the next one we know is going to be negative. So we don't honestly have to plug it in for the negative. You could just look at the exponent of the 2. And so this becomes negative 32. So our sequence for the first 5 terms are negative 4, negative 8. Let me get rid of that. Negative 8, 16, and negative 32. So by putting a negative 1 with an exponent there, you'll get this alternating. So we've been plugging things into our general terms. Now it's time to create the general term. So find the general term of a sequence whose first 4 terms are 5, 6, 7, and 8. So you can already see that they're just the whole numbers from 5 to 8. So the first thing you want to do when you do these is to find out what the difference is. The difference here is 1, 1, 1. Anytime you have a constant difference, that little difference that we get is our coefficient for our n. You got to think of it, these are slopes. So when they have a constant change like this, a constant rate of change, that's a slope. So if you remember y equals mx plus b, right? What we have is a constant change and a starting point, right? But that starting point is for 0, not for 1. So it's a little different. It's 0, comma b. So what we're going to have here now is a sub n equals, right, mn plus, and then I'm going to call it something else, just start. Okay, so we can use the same idea. So when you make your general term, it's a sub n equals, and our difference is 1 and then n. And now we just have to make sure our first term becomes 5. So we plug in 1. 1 times 1. Let me put that 1 in green. And then plus what will equal 5 is all you have to look at. So what's 1 times 1? That's 1. So 1 plus what would make 5? You guessed it, 4. So if we add 4 to our 1 times n, we get our formula. And you can check this again. We check a sub 2. So 1 times 2 plus 4 is equal to 6. And then if we want to just keep going, 1 times 3 plus 4 equals 7. See, it checks perfectly. So this is our general term. So let's try it again. So our difference here, you can see, is 2, 2, and 2. So we know it's 2n. So it's a sub n equals 2n. And then our first term, plug in 1, plus something or minus something has to be 2. So if we add 0 to it, you get 2 times 1 is 2 plus 0 is 2. So we don't have to add anything. This is our general term. And you can check it very quickly by just plugging in the numbers, and you see it creates it. Okay, so for our next one, you can see it has a difference of 2, 2, and 2. So like if you had 3, 7, 11, that's a difference of 4. So that would be 4n. So we'd have a sub n equals 4n plus or minus something. So since this has a difference of 2, that's where we're getting our 2n. So it'd be a sub n equals 2n, and then we're going to add or subtract something. So we check our first term, and it doesn't really matter. You could check any of these terms. They just have to be correct. So we're going to plug in 1, and this has to equal 1. So you can see that if we subtract 1, this would now be correct. 2 take away 1 is 1. So that means our general term is 1. And then I still like to check another one. So that would give me a sub 2 is equal to 4 minus 1 is 3. And so there's my second term right there. All right, so that's how we do those general terms. Now let's look at another one. So the next one here, you can see that there isn't a difference of 2. This one is actually a difference of 2 and then a difference of, you guessed it, 4. So this is not a slope problem. You can actually see that this is a multiple. From here we have to times 2, times 2, times 2. And if you go back to our exponentials, that's a doubling, yes. So this is a 2 to the n problem because it has a double of 2. So we say a sub n equals 2 to the n, and then we do the same thing to make sure it matches. So we plug in 1, 2 times the power of 1, and that equals 2, so it checks. That is our general term. All right, the next one is for you. I want you to put this stuff together and see if you can figure it out. So you can see we have a multiple of 3 here and an alternating. So you're going to be using those two situations, the alternating and the multiple. And you just have to get creative. I've already given you a hint, so give it a shot. Hit pause now and try. So you should have gotten this. You should have thought of each one as what they are, which is this. So how do we create the first one to be positive? That would be an n plus 1, so that when you plug in 1, you get 2, you get an even. So if you want the first one to turn out to be positive, you use n plus 1. And if you want the first one to turn out to be negative, you use just n. It's that simple. And then this had a multiple of 3, so we did 3n. So it's 3 times 3 times 3 times 3, and there you go. That is our general term. Thank you.